So hey guys, welcome to my channel, and topic for today is going to be recursion. So this is going to be video number 1 of recursion playlist. So let's get started. So what is a recursion? Before understanding recursion, before explaining recursion, let's understand where is it useful first. Okay, so we have recursion used in dynamic programming to solve an abstract problem. Many dynamic programming problems that use recursion, and the basis for dynamic programming is recursion itself. So the unoptimized solution that you write is using recursion. We then optimize this recursion solution to the iterative one. Okay, so in DP it is useful, in backtracking it is useful, it is the same story in backtracking. What about divide and conquer? Okay, we write merge sort, we can write merge sort using recursion as well. So this is one of the use case of recursion. Then we have tree traversal, that is pre-order and post-order. These two can be done using recursive calls. So this can be implemented using recursion. And the graph traversal itself is a recursion itself. So recursion actually rules them all. So you have these branches, and there are many branches that recursion will fall into. Okay, so it is more of one single concept, one concept that will rule them all. Okay, so if you know this concept, if you have a good grip on this concept, most likely these all concepts are going to be much easier. Specifically, backtracking is going to be very easy for you if you understand this particular concept of recursion. Okay, so let's do a basic test of what is recursion, and let's understand what is a recursion. So let's say you have this door, and this door has a superpower that if you visit this door, if you open the door with normal handle, then it is going to take you to the same door again. Okay, so you as a person visit there, open this, it is again going to take you to the same door. And there is also a button, let's say this red button. If you click this button, then this link that which it takes you to the next button breaks. Okay, so once you press this button, then the link is going to break. Okay, so for first time you visited the door. After that, the second time you again visited the door, you didn't press the button. Third time you visited, you didn't press the button. And fourth time you visited, let's say at this point you pressed the button, the red button, then the link is going to stop and it is not going to move further. So what just happened? Okay, so this is what recursion actually means. You're doing the same thing again and again until you hit a condition. So in this case, pressing this button was the base condition. Okay, and this is actually we are looping again and again and again. Okay, so until you press this button, if you press this button, everything is going to stop and this link will just break. Okay, so this breaks the entire link. So that is recursion in a very layman terms. So let's just understand the technical definition of a recursion now. Okay, so in technical definitions, what we can say is we have a starting condition that I start, then I visited the door, and then I had two options that if I press the red button, then something will happen. That is, if I press the red button, I'm going to stop. If I don't press the red button, I will continue and open the door. Then again I'll visit the same door. Then again it will ask me same condition. Is the red button pressed? I again say no. The red button is no. I don't press the red button. Then again it is going to ask the same condition. This happens until you press the red button, and as soon as you press the red button, everything is going to stop. Okay, so you visit the stopping condition when you press the red button. So till then what you can say is you visited the door, didn't press the red button, it called, you again visited the door, didn't press the red button, it again called the same door, again same door, again same drum, and this is going to go till the end. Okay, end of your memory. Otherwise, at any given branch of these, you could have pressed the red button, this could have triggered the red button, and everything would have been stopped. Okay, so That's the general definition of recursion. You're going to visit the same condition again and again. Okay, so let's understand this with an example. We want to print something and we want to print number between 0 to 5. And as soon as we reach number 5, we want the program to stop. But the catch is we cannot use any for loops. Okay, so this problem can be solved using recursion. We are not allowed to use any for loops, so but we can use recursion to solve this. So let's say I created a function def print num, and the parameter that I gave n equals 0. Again, I'm going to check if n is greater than 5. If that is true, then I'm going to return. Otherwise, I'm going to print the number, whatever number I have. Okay, after that, I'm going to call the function. Okay, call this function again, but with n as n plus 1. Okay, so this, I do have a base condition. So this part is what base condition is going to represent. This is my base condition, and this is my recursion body. Okay, so I'm just writing body for now, but that is recursion body. So how does the call stack look like for this? Okay, so let's say you called print num of 3 or print num of 0. Okay, so the next thing it had to do was it had to call this particular function. It had to check if n is greater than 5. So I called with n as 0. So is 0 greater than 5? The answer is no. This will not be this will not be called. It will go and print something. What will it print? It will print n hyphen arrow, and it is going to print 0, whatever the value of n is. Okay, after that I'm going to call the function again. So at this point I'll call the function again. So it is going to call print num 1, and this is going to print n as 1. Okay, and then it is going to again call the function, that is n plus 1. Once I call the function, it is going to be print num 2. Okay, so it is going to call for 2. So what happened, we went for 0. Okay, we checked if 0 greater than 5. The answer was no. So this ran, and then we called the function again. This time it is going to be print num 1. So we went 1. Okay, is 1 greater than 5? The answer is no. So this is not going to run. This prints out the number. Then we call the function again with n is equal to 2. Okay, now we called n is equal to 2. So it again printed the result. Since this condition will fail again, n equals 2. It printed, and it again called the function print num 3. Okay, after calling the function 3, it again check if n is greater than 5. The answer is no. So, but it printed at that point n as 3. Okay, so we again call the function print num 4. We again check the condition, is 4 greater than 5? The answer is no. We again print the value, that is 4 is going to get printed. Then we again call the function with n plus 1, print num 5. So now it is going to check if 5 is greater than 5. The answer is no. So it is again going to print n as 5. Then it is going to call the function again, print num 6. And at this point it is going to check is 6, at this very point it is going to check is 6 greater than 5. The answer is yes. Since 6 is greater than 5, it is going to just return. Okay, from this point. If you return from this point, this too won't be executed. Okay, so this returns. So after calling for 6, it is going to stop. So it is going to return. So this is where the base condition will hit. So what we printed in the terminal was this blue line. We printed n is equal to 0, 1, 2, 3, 4, and 5. Okay, after we reached the end, we returned. So let's see how it works in terms of code. Okay, so let's just do the coding part of this. So the main aim for the program is to print from 0 till 5. Okay, so I can solve this using def print num, and I'm putting it in Python, and I can say n as 0. So if n is greater than 5, I'm going to return this at this point. Otherwise, I'm going to print the number whatever I have, and it is going to be n, and then I'm going to call the same function recursively. That is n is equal to n plus 1. Okay, so recursive call. This is where the recursive call is. So I can just print num, that is n is equal to 0. If I print num at this point and if I run the code, it should print from 0 to 5. Yeah, so this works and it prints 0 to 5 at this point. Okay, so let's just get back and understand it even further. So let's understand how we can solve the Fibonacci number. So we have Fibonacci series. We all know that it is nothing but sum of previous two numbers. So for 0 and 1, the Fibonacci is 0 and 1. But for 1, the Fibonacci is going to be in addition of these two numbers. And for 2, the addition of the 2 is made with addition of this. 3 is made with addition of previous two numbers. 5 is also made with the addition of previous two numbers. Like that, the series is going to continue till infinity. Okay, so how can we solve this using recursion? If you want to find out Fibonacci of, suppose, let's say 5 or Fibonacci of 6, so let's say 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the indexes I've already set. So if you want to find Fibonacci of 5, how will you do it? Okay, so we all know Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So we can use this fact to our advantage. Def Fibo. Okay, and what it takes a number as the input and it checks. We all know two things, that Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So I can say if n equal 0 or n equal 1, in this case I want to return n. Okay, so I can rewrite this condition, that is if n is less than or equal to 1, then I'm going to return n. Otherwise, I know Fibonacci is calculated with Fibonacci of previous and current number, previous and its previous number, that is previous two numbers, this and this. For if you want to find out Fibonacci for 2, it's going to be like this. So let's say if you are at this point, let's say you are at this point, that is Fibonacci of 4, you need Fibonacci of 3 and Fibonacci of 2. So I can say that I calculate the previous digit. Let's say this I store it in a variable called as x, and this I store it in a variable called as y. So x can be Fibonacci of n minus 1 and y can be Fibonacci of n minus 2, and I can return x plus y after this. Okay, so what this will do is it will call the function again same function but with a new argument, that is n minus 1, reduced n. Okay, so if you want to find Fibonacci of 5, it will check if the n is less than equal to 1, the answer is no, then it is going to do a call n minus 1, that is it is going to go and call Fibonacci of find Fibonacci of, so I want to find Fibonacci of 4. So to calculate Fibonacci of 4, I know we can do Fibonacci of 3 and Fibonacci of 2. Fibonacci of 3, if you want to find, it will call Fibonacci of 2 and this will call Fibonacci of 1. But we already know the answer of this. The answer of Fibonacci of 1 is always 1. Okay, so when it comes to 2, it again finds Fibonacci of 1 and Fibonacci of 0. These are the last two numbers. Again, for Fibonacci of 2, we are going to do a call Fibonacci of 1 from a Fibonacci of 0. So this is the call graph for the Fibonacci numbers, and this is how the the recursion tree will look like. Okay, so the this code stops when we hit the base condition. That is, in this there are many base conditions. Okay, that is, if you reach 1 and 0, then you're going to stop the execution of further. You're going to return from that point. Okay, so it is going to roll back, and is going to roll back further, roll back further, roll back further. But with each addition, suppose this will give you 1, and from this point it will give you 0. Okay, so you plus them up, the answer is going to be 1. So from this point it will go up, and from this branch 1 will be returned. From this branch, what is Fibonacci of 1? 1 will be returned. So you again, when you go back, when the recursion rolls, you're going to you have two options, that is x plus y. So from x side you get 1, from y side you get 1. Then you add them up and you return back. So you get 2 from the left branch, and when you go down at the bottom as well, you're returning 1 and 0. You add them up, you get 1. So 2, 3. Then you add them up and you give back this as the answer. So 3 is going to be the answer in this case. So Fibonacci of 4 is solved. So what is Fibonacci of 4? It is 3. So why is it 3? Because when we return, we are adding it up. Okay, so when we are returning, we are adding it up. So that is how it is working. So let's understand with this another example. So I want to find factorial. What is factorial? Okay, factorial is a number. Let's say 6 factorial I want to find. 6 factorial is nothing but 6 times 5 times 4 times 3 times 2 times 1. Okay, so this is 6 factorial. But what about 5 factorial? Okay, it's going to be 5 times 4 times 3 times 2 times 1. But what about n factorial? What if I want to find n factorial? Factorial of n number. So this is nothing but n times n minus 1 times n minus 2 times n minus 3, and this is going to continue till you multiply it by 1. Okay, the last is going to be 1. Okay, so if I want to find the factorial of n, I need to know the factorial of previous number. Okay, if I just know the factorial of previous number, this number, I can multiply it with n and get the answer. Okay, so suppose I can rewrite the 5 factorial as I can rewrite the 5 factorial as I can rewrite this as 5 times 4 factorial. So now the problem boils down to what is 4 factorial. I don't know that. Okay, so I know what is 5, but I don't know what is 4 factorial. So I'll do a call again and I'll try to find the 4 factorial. But how is 4 factorial calculated? So 4 factorial is nothing but 4 times 3 factorial. Okay, so what is 4 times 3 factorial? Okay, so what is 3 factorial? 3 factorial is nothing but 3 times 2 factorial. What is 2 factorial? 2 factorial is nothing but 2 times 1 factorial. And this is the base condition. 1 factorial is always going to be 1. Since we know this, 0 factorial is 0 and 1 factorial is 1. Okay, so if you want to find factorial of 5, you have to find factorial of 4. To find factorial of 4, you need to find factorial of 3. For 3, you need 2, and for 2, you need 1. But at this point, you're getting 2 factorial times 1 factorial. So this is just going to be 2 times 1, right? So 2 ones are, that is going to be 2. So it is going to return back 2. Then you're going, so this whole thing is evaluated to 2. So you multiply these two numbers. What is 3 times 2? The answer is going to be 6. So you return back 6. So this is what you return. Then you're again going to multiply 4 times 6. And you're going to return the result. What is going to be 4 times 6? It's going to be 24. So this will be evaluated to 24. Okay, so 5 factorial is going to be 5 times 24. What is 5 times 24? 120. So this is going to return 120 as the final answer. I want to find factorial of number. So n is going to be the input, and we know the factorial of 0, that is n equals 0, or n equal 1. We have to return 1 as the answer in this case. Okay, so if the n is going to be 0 or 1, we are going to return 1 as the answer. Otherwise, I'm going to return n times, again I'm going to call this function, recursively call this function called as factorial. So n times factorial of n minus 1. So this will work as well. Okay, so this is the code of it. And let's see the call graph of all three codes that we have done till now in the visualization. Okay. Okay, so let's understand the call graph for factorial. So I want to find factorial of 4. It called factorial of 3. Factorial of 3 called factorial of 2. And we know factorial of 2 called factorial of 1. Factorial of 1 is always going to be 1. So let's see this in action. So 4 called 3 called 2 called 1. And the answer of 1 is 1. So it returned 1 as the answer. 1 multiplied by 2 is going to return 2. 2 multiplied by 3 is going to return 6. 6 multiplied by 4, this is going to return 24 as the answer. Okay, so let's understand the call graph of Fibonacci series. So to calculate Fibonacci of 4, it first went and called Fibonacci of 3, and it called Fibonacci of 2. Okay, for Fibonacci of 3, it called Fibonacci of 2 and Fibonacci of 1. And we all know Fibonacci of 1 is 1, so it returned 1 as the answer to the arrow. But for Fibonacci of 2, it called Fibonacci of 1 and 0. From this point, we got 1 plus 0, that is 1 as the answer. It traversed back, so 1 plus 1. From this layer, we got 2 as the answer, so it returned 2. And from 2, and then on the right side, we had 1 plus 0, that is 1 as the answer. And this time, 2 plus this 1, that is going to be 3 as the answer it returned. So that is it for the video. See you guys in the next one. If you like the content, kindly subscribe. Bye.